Okay, 2012 AMC, this is problem 12 from the AMC12B, and it says how many sequences of zeros and ones have length 20, have all the zeros consecutive, or all the ones consecutive, or both. So here's the idea. I have some sequence, and I'm going to split into 3 parts, okay? And this middle section has to contain all the zeros, and then I can have some ones over here. I don't actually need to have any ones over here. I could have some ones over here as well, so long as there are only zeros here and only ones on the edges, or the other way around, I could have ones in the middle and zeros on the edges, and any one of these sets can be completely empty. I'm going to look at the case of zeros alone, and I'm going to use that then to count how many ones that we have, and I'm going to sort of double it, but I'm going to make sure I don't overcount things. So first off, so let's see, we'll count this as zeros. So the number of ways that we can have it, and then I'm going to say, okay, but I'm also going to leave myself a column for how many I will overcount when I multiply by 2. So what that means is if I have all the zeros on the left and all the ones on the right, that will be counted as a group of zeros alone and a group of ones alone, and I have to make sure I take care of that. So if I have 0 zeros, there is going to be one way to have 0 zeros, but that will be overcounted when I double it because that's also the same thing as having 20 ones. Okay, if I have 1 0, there are 20 ways I could have that, any one of the 20 locations. However, if it's on the far left or the far right, then I'm going to have too many. If I have 2 zeros, there are 19 ways to have that, and again, 2 of them overcounted for all the zeros on the left or all the zeros on the right. If I have 3 zeros, there are 18 ways that I can have 3 zeros next to each other and the rest be ones, and 2 overcounting, all the way down to, if I have 20 zeros, there is 1 way to count that, and it will be overcounted when I have that. So what I'm going to look at is this right here is going to be the sum of the numbers 1 to 20. So 1 plus 2 plus ... plus 19 plus 20. And we should know there's a trick to this. If I add the outside 2, I get 21. If I add the next outside 2, I get 21 again, and so forth and so on. And I have 10 groups of that. So that's 21 multiplied by 10. 210 ways. And I have this right here, which will allow me to have 211 ways to have all the zeros consecutive. Okay? All consecutive zeros. I can count the same way and say, okay, well then there are 211 ways to have all consecutive ones. Okay? The only problem is that there will be this many overcounted. Okay, so, and that's going to be 2 times 19 plus 2 more, so 2 times 20, which will be equal to 40. So let me make that in red, a nice red 40, meaning that I have too many of that, so that's overcounted. It's counted in the zeros and in the ones. And that means 211 plus 211 is 422 minus 40 gives me 382. Total number of sequences, my answer is E.